All right, good morning and welcome back. Here we have all of our notations for whenever our intervals are open or closed. First one, AB, is open in both directions. That's why it has parentheses on both sides. So if it has parentheses on both sides, it's open in both directions. The second one, AB with the brackets, that would be considered closed. That's closed because there's the less than or equal to sign on both ends. The third one is half open because I have a bracket on this side and a parenthesis on this side. That's because I have less than or equal to and then just less than. This one is also half open, and that's because I have a less than and then less than or equal to. Bracket means it comes up here and stops. It includes the point B. For infinite, it would be open if it's parentheses on both sides. Specifically, you would see open if its x is greater than a number. And it's going to be starting at A and going to infinity because it's all the numbers that are bigger than this number. Closed is if it's closed on this side, x is greater than or equal to A, and then going on to infinity. Open if x is less than b, because it's all the numbers that are smaller than b going to negative infinity. Closed if it's x less than or equal to b, simply because we have the equal sign underneath. And lastly is all the numbers from negative infinity to infinity. That's the set of real numbers, which includes every number that's not imaginary or complex. And that would be both open and closed. Why? Well, because if I pick specific numbers out, they are contained, but it goes on forever. So we wouldn't really consider it open because any number I pick is contained, but we wouldn't consider it closed because there are numbers I haven't even thought of yet. So it goes on forever in both directions. That's why that one's both open and closed. No trick questions. I probably won't ask you that. Or might I? Who knows? All right, solve and graph the following inequalities. We've done this before, Algebra 1, Algebra 2, pre-calc, lots of times. So let's go ahead and solve this. We'll subtract the x over. First, it gives us x minus 1 is less than 3. Add the 1 over, x is less than 4. If I want to put this on in interval notation, then this is going to be from negative infinity up to 4, and it's a parenthesis because this is just a less than. Part B, this one's a little bit different. We're going to have to subtract the 2x over. Here we go again, Loriana. Who do you think it is? It's not Brennan this time. All right, so when I subtract this 2x over, I need to get a common denominator, which means I multiply the bottom by 3 and multiply the top by 3. That's negative 6/3 that I'm subtracting now. So that gives me negative 1x over 3 minus 6. That's negative 7x over 3 is less than 1. Now, in order to solve this, we multiply by the reciprocal. Negative 3 over 7, negative 3 over 7. That gives us x. Now, when you multiply or divide by a negative, you flip the direction of the inequality. X is greater than negative 3/7. Putting that in interval notation, that's going to be parenthesis, negative 3/7, comma, infinity. Next one, in order to get x minus 1 off the bottom, I have to multiply both sides by x minus 1. So to cancel those out, gives me 6 is greater than or equal to 5x minus 5. Add the 5 over. 11 is greater than or equal to 5x. Divide by 5. You get 11 fifths is greater than or equal to x. That's the same as x is less than or equal to 11 fifths. Put that in interval notation. It's going to be parenthesis, negative infinity, comma, 11 fifths. Now it's got the equal sign to it, under it, so it's a bracket. The other way I could have done this one would have been to flip it. Gives me x minus 1 over 6 greater than or equal to 1 over 5. Multiply both sides by 6. It gives me x minus 1 is greater than or equal to 6 over 5. Whenever you flip it, though, whenever you flip it, you have to flip this inequality as well, though. So it's less than or equal to 6 over 5. Then I add the 1 over, which is 5 over 5. Gives me x is less than or equal to 11 fifths. I get the same answer here. Negative infinity to 11 fifths. Bracket. So those aren't too bad. We're just solving the inequalities and setting up the interval notation. Takes us to absolute values. The absolute value of a number x, denoted by the two lines around the x, is defined by the formula. The absolute value of x equals x as long as x is greater than or equal to 0, and negative x if x is less than 0. So this is a piecewise function. We did some of these last year. Now, a lot of you would look at this and simply say that the absolute value is always positive, which is pretty much true. So what's the need for this formula? Well, the reason to have this piecewise function here is that if this is a negative 6, it tells you it's a negative of whatever's inside of here. So the negative of a negative 6 is a positive 6. That's how the absolute value is true. Here, if x is greater than or equal to 0, which 4 is greater than or equal to 0, then it just stays the same. When we look at absolute values in intervals, if a is any positive number, then the absolute value of a, or the absolute value of x equals a, if and only if x is a positive or negative a. Absolute value of x is less than a, only if x is in between negative a and a. Absolute value of x is greater than a, if and only if x is bigger than a or x is smaller than negative a. And then its absolute value of x is less than or equal to a, if and only if x is between negative a and a. Absolute value of x is greater than or equal to a, if and only if x is greater than or equal to a, or x is less than or equal to negative a. There's a lot of different ways to say some things we kind of already know. If x is negative 6 and a is 5, then negative 6 is less than or equal to negative 5. So if I take the absolute value of negative 6, that's going to give me 6, which is greater than or equal to 5. Basically, those come into more help whenever we're doing absolute value inequalities. These are not inequalities; these are just regular equations. But guess what? We're going to get to. Going to get to the inequalities right after this. This is just making sure we remember how to solve absolute value equations. So the first thing I have to do is get rid of my lines here. So whenever I do that, it means that I set up two separate problems. 2x minus 7 equals 3. 2x minus 7 equals negative 3. And that's because there are two solutions, there are two numbers that I can plug in to make this true. So now let's solve that. 2x equals 10. 2x equals 4. X equals 5. And x equals 2. Oh, it's time for the word of the day. The word of the day is two words, absolute value. Send me an email with the words absolute value in it. You can get 5 bonus points on either your chapter test or your next quiz. I think we'll put it on the next quiz maybe. I don't know. We'll figure it out. Either way, you get 5 bonus points. All right, on to the next one. Here we have absolute value of 4x minus 5 equals negative 6. I want you to do this one on your own. I'll sit here and wait. I'm not playing with you. Get started. It seems like I'm going to wait forever. And the reason that I would be waiting forever if I was waiting on you to do it is because I would sit around and I would wait. And then as soon as you're done or you think you got the right answer, I would tell you how wrong you are. The reason for that is any absolute value has to equal what? If this is an absolute value, it has to equal a positive number. In this case, I have an absolute value set equal to negative 6. So this is no solutions. An absolute value by itself cannot be equal to a negative number. Got them. All right, now let's move on to inequalities. We treat inequalities the same way with absolute values. If I have 6 minus 3 over x less than 8 in the absolute values, I do the same thing. Get rid of my absolute values. That gives me 6 minus 3 over x less than 8. Then when I rewrite that, 6 minus 3 over x, make that negative 8. Whenever I make this negative, I have to flip my inequality. It's going to become greater than negative 8. You have to do that every time. It's because it's like we're multiplying by a negative. All right, subtract my 6 over. This gives me negative 3 over x less than 2. Multiply both sides by x. Gives me negative 3 is less than 2x. Divide by 2. Negative 3 halves is less than x. So x is greater than -3/2. Let's do this side now. Subtract the 6 over. It gives me -3 over x is greater than -14. Multiply both sides by x. Gives me -3 is greater than -14x. Divide by -14. Now I'm dividing by a negative. It gives me 3 over 14. Change the direction of my inequality because I divided by a negative. Less than x. And then I'm done. X has to be greater than 3/14. Sorry, I was just going over my work there. Everything looks correct. All right, that's really the end of this section. It's going to have a lot of review in this chapter. Things that we did in Algebra 2 and in pre-calc. Overall, it can be kind of tough because it's a lot of things at once. But I know you guys have it in you.